In this video, I'll be going through network flow or flow problems, different types of flow problems, which matches up with 15A in your Cambridge textbook for Year 12 Further Maths. My advice to follow along with this video is just to quickly do a sketch of the graphs that I'm doing, just so you can see and have a go. Pause the video and have a go yourself when we get to the examples. So network flow, let's get into it. So network flow, a flow is a quantity that can be moved from one point, and it's commonly referred to as the source. So the starting point of the flow of whatever is called the source, and to another point, which is called the sink. So where it leaves is the sink. In the network below, the edges, before I get into that, this flow could represent anything from water flow, traffic flow, heaps of different things that it could mean. But it's the flow of something through a network from the source to the sink, right? So having a look at an example, the below network, the edges represents roads. So this might be one town to another, and the weight on each edge represents the maximum number of cars that can use the road at a time. So if we break this down from one path to the other, so for example, if I'm going from A to B to C to E, and I'm looking at the traffic flow. So between A and B, I can fit 300 cars. So they're going to go fine along there, no worries. My 300 cars, I can't fit any more through in there. And then they get to this part of the road here from B to C, and those 300 cars fit very easily in that section of road because it's designed for 600 cars. So they would cruise along quite easily, no worries. But what's going to happen here in this section of road from C to E is I can only fit 200 cars. So I'm going to have 100 cars not be able to get through here. I can only fit 200 through. So if I'm thinking about this path through here, the maximum amount of cars that can fit comfortably the whole way along is 200, right? So only 200 is the maximum through that part of the network. If I have a look at the other path, A, D, E, I have 500 at the start. So this is a nice big road. Maybe it's 5 lanes of traffic. I fit beautifully 500 cars at a time through there. What's going to happen at point D is I have a massive bottleneck. So I've got congestion of about 350 cars because only 150 can fit through for this section of road. So if I'm giving a statement about the maximum amount of cars through this section, I can say that comfortably only that 150 can make it through this section. So if I'm talking about from the maximum flow of the source to the sink for this network, I know that I've got 200 cars here through A, B, C, E, and I've got 150. So the maximum flow of traffic through this network is 350 cars. So that is a really simple way of looking at it. In your textbook, it's got a really nice diagram of like pipe work where you've got like a big section of pipe that fits 300 litres through, and then it comes into a really small section of pipe that only fits in 100 litres. So obviously through that section, through the whole thing, you're only going to get through 100 litres at a time, all right? Have a look at your textbook if you would like to see that in more detail. All right. Now, into the actual method of how we work out maximum flow. So this one is a little bit weird to think about, but our maximum flow is given by our minimum cut. And I'll explain cuts in a second, but that's the big takeaway here. So maximum flow through a network is found by the minimum cut. All right, so how to do this is we have to do a series of cuts which must stop the flow from the source to the sink. So if this was water coming through and coming out to the sink, I must not have any water to the sink. You must completely cut off the source to the sink, right? So for example, and I'll rub these out, if I made a cut like that, so I'll have some water coming out here, it will be cut off, and then it will be cut off here, so I'll have no water getting to the sink. However, if I do a cut like that, while I'll cut the water off from this way here, my water is still able to get to the sink through here. So we call that an invalid cut. So we don't count that one. All right, so let me just get rid of all that so it's a little bit easy to see. All right, so what we're going to do is we're going to make a series of cuts that will cut off the source from the sink. I'm going to do these in red so you can see. So the easiest way to do this is just by probably starting right at the source and then going your way through to each section. So for example, and when you do a cut, it's like an imaginary cutting of paper. So think like perforated lines. So you're going to do like little dashes to represent that you're cutting that off. So like this. Right? So that is one cut. Now I need to see whether it's valid. It is, because it does cut off the source from the sink. And what I want you to do is once you do the dotted line, this sneaky trick in here, once you draw the dash line, draw a parallel full line to the sink side of the cut. What I mean by that, so once you draw your cut in, draw a full line next to it. This will make sense in a second. So that's one cut. I think the easiest way to do this is, because I'm starting on this section here from A to B, I'm going to use A to B again, and I've cut off in here, I've cut off that part there with that part there. I'm going to do the same AB, but I'm going to cut it off here. So what I mean by that is like that. So because I'm cutting off different sections of road, it's a different cut. So I'll call this cut 1, this one cut 2. Now this does get a little bit messy, so if you can draw it nice and big and avoid it all clumping up, that would be good. So I've used A and B with every section I can on the bottom set of roads. So I'm going to do the section B to C and look at those cuts. All right, so through here, need to get my dotted line, sorry. So through here and through here, we'll call that cut 3, and then match it with unbroken line. And I'm going to do the same thing. So I've cut off B to C with A to D, and that's completely cut off the source from the sink. And I'm going to do the same thing the same thing through here. So my dashed line, my solid line, this is going to be C4. So I've done that, and now I'm going to do the same thing with C to E, length of road, with A to D, and then C to E to D to E. Like I said, this gets really a little bit messy, so I'll do my best to try and keep it neat. So what am I up to? C5. And last one, C6. Boop. All right, so I've looked at all possible cuts of cutting off the source from the sink. I want all valid cuts. I want nothing that can not completely cut off the source from the sink. So I think I've done that. Now I need to look at the value of each of my cuts. And what it is just the weight of each of your lines that you have cut off in the cut. So if I'm looking at C1, cut 1, I've cut off this line here, or this road of 300 cars, and I've cut off this road here of 500 cars. So altogether I've cut off 800 cars. All right, let's have a look at, we'll do C3, even though it's not in chronological order, it doesn't matter. So if I follow this up, so I'm going to cut off this road here, which is 600 cars. So 600 cars, and following that down, so, and I'm going to cut off the 500 cars as well. So altogether, that's 1100 cars. C5, let's have a look at this little guy. So up here, it's going to cut off the 200, and then down here it's going to cut off the 500, which is 700 cars in total. For C2, that should be cutting off AB, which is 300. It's a little bit hard to see, sorry about that. And then if I follow that line down to here, it's going to cut off the 150, which is 450. C4, let's have a look at that one. So up here, it's cutting off the 600 plus the 150, so 750. And then finally, the C6, the cut 6, is cutting off the 200 and the 150. So 200 plus 150 is 350. Now, again, taking you back to this little guy, your maximum flow is given by your minimum cut. Once you have all your cuts in place and you've established the weight of each of your cuts, you're finding the minimum cut, which will be your maximum flow. All right, so taking you back to, I know like that sounds a bit weird. How can a minimum cut be maximum flow? But thinking about what we did back here with our traffic through this way, that 500 road, and then it bottlenecks to 150. Only 150 can get through there. So that's why we're looking for the minimum cut, because it's going to give us the, eliminate all the bottlenecks and tell us the maximum flow through a network. I think probably the trickiest thing about this is finding all the cuts, because they can bend and stuff like that. Now, this was a nice easy one where our flow was one direction. The reason I'm getting you to do these dotted lines and the solid line is for this reason in here. So, for example, if we have a look at the value of this cut through here, so this is a source, this is a sink. So if this is like, I don't know, water coming through here, so the water's coming through the pipes and then it's going down in the sink in here, I want to look at this cut here and the value of this cut. Now, like I said, you do a dashed line and then you do a solid line beside it. The reason for that is a cut, you only count the weight of a line that you cross if it's coming into the dotted line. For example, if we're looking at this cut here and looking at A to C, the direction of the line is very important. So it's going this way here, right? So it's going this way and it's going to hit that dotted line first. If this was water, it would hit that dotted line first. So I'm going to count that 6. The 6 is counted. Similarly, if I look from B to D and look at the direction of the line, so it's flowing this way. So if it's flowing this way, it's going to hit that dash line first. So it's hitting the dash line first, we pay it. So that is 4. Now, let's have a look at this one. From C or B and C, the line in between B and C, see how it's going in the other direction? Be very careful and to pay attention to the direction of your lines. So this pipe here is feeding back in to the source direction. So it's going to hit that unbroken line first. If it's going to hit that unbroken line first, that means it's already been cut off, because if we're cutting it off here, it's already going to be cut off, so we don't pay that one. The reason why we do the dash lines and the solid lines, it's like thinking about your road rules. So if we can cross over a dotted line, but we cannot cross over a broken line, right? So we pay the dotted lines, but we do not pay the solid lines, okay? So the value of that cut is only 10. We don't add the 5, because if the water was coming through here and then feeding back up through that way, we would have already cut it off. So that is why we don't pay that one. But the easiest way to get around that is just to do your dashed and your solid line. So remember, the solid line goes on the side, where have I said that? The sink side, right? So once you do a dotted line, so if this is your source and this is your sink, put a solid line so you don't get confused. All right, let's have a look at some values of a cut. This is a really common exam type question. They'll give you a series of cuts. These are not all the cuts on this network, but there's a couple, and there's probably a trick in there. So just pay attention to the direction of the lines. All right, so for cut 1, let's have a look. Once again, let's go our solid line. So this is our source, this is our sink. So I'm doing a solid line on the sink side of all my lines so I don't get confused. Very easily done. So got to put that in place. All right, so let's look at cut 1. So cut 1, the direction of S to B is going this way. So I'm going to hit that dotted line first. So I've got 6 plus, and then the other edge it cuts off is this one here, which is going in this direction. So it's 8. So both of those are counted. So 6 plus 8 is 14. All right, so that is the value of that cut. Let's have a look at, we'll go C3, and I'll do it in a different color. So looking at the edge that it first cuts off, cut 3, from B to C, it's going this direction. So it's going to hit my dash line first, so I can pay that one. So it's 8 plus. And then if I follow that through, it's going to hit this line here from E to C. So E to C, it's a bit hard to see, but the direction is going from E to C. So once again, sorry, that's a bit hard to see. I'll do purple. So once again, it's going to hit your dash line first, so we can pay that 10. Moving on, we've got one more, as I follow that cut through, I've got one more line from E to the sink or T. And again, that's going to hit that dotted line first when I pass through there. So I am going to pay that one too, which is 3. So I've got 21. All right, now let's have a look at C2, this little guy. Right, so following that cut through, the first edge I'm looking at here is C to T. Going in this direction from C to T, it's going to hit that dotted line first, so I can pay that. Keep turning on my eraser. Right, following that down, I've got this line here that's coming up through the cut like this. So coming out through the cut like this in this direction from E to C with my cut, can you see how it's going to hit my full line first? So it's hitting the full line. It's not a countable edge because it's already been broken off somewhere else. So I'm not going to count that one. All right, moving on. If I follow this cut through here, so I need to look at this edge from E to B. From B to E. So it is going this way here. So looking at the direction of the line, it's going to hit the dashed line first. Ripper, I can count that. So I've got the 5. And then finally, I've got this line over here. So looking at this, going along from F to E in that direction, going F to E, it's going to hit that dotted line first. So it's 4. So I've got 8, 12. So that's 12. Okay, so that's just an example of how to determine the value of each cut. Once again, it is very important for you to look at the direction and pay attention to the direction of the line and have your dashed line and your solid line. And just remember, if the direction of the line would hit the dashed line first, you pay it. If it hits the solid line first, you do not. Okay? All right, we're going to have a crack at 1. So that was just an example of the value of the cut. We're going to have a look at doing the whole shebang-a-bang. So determining all the cuts and finding all the values of this little cutie. Sorry, it's a little bit blurry. It didn't transfer super well. Okay, so the first step is we need to find all our cuts. So I'm going to do those in red. Like I said, it's the easiest way to do it is to sort of start. I always start from a section and make sure I'm cutting off each of the sections with each of the other parts. So if you've got 2, because we've kind of got a section like that and a section like that. So if I'm doing this section, I've got to do that section with this section with that section and so on and so forth. It just comes with practice, really. All right, so let's do cut 1. We'll just go through like this. I'm going to call that cut 1. And then I'll do my solid line. All right, so I've done S to A. I'm going to do this one. And I'm going to call that cut 2. Like I said, this does get a little bit messy, so as neat as you possibly can would be amazing. We could go, so that one is broken off in there, so I could also go like this, which cuts off a different section. Ugh. So see how this one over here was cutting off the 3 and the 1, whereas this one was cutting off the 5 and the 1, so that's a different cut. So cut 3. So I've pretty much done that section of road or pipe or whatever, S to A, for every other section of the network, so I can move on. I might even do it in a different color pink so we don't get confused, or I don't get confused, which is so easily done. All right, so A to T, I'm going to start cutting off sections here. So my cut is through like that, and then my solid line. So what am I up to? Cut 4. What else can I do here? So I've done that. I could go that part, so over here. So still the same length of line, but I'm now going to cross over like that. Which is a different cut because it's now cutting through that one. So that's C5. Where else could I go? I've done that one. I could go, now that I've done, I think I've done all of those ones with that top line with that section in the middle. So I might go the top one and the bottom, which I haven't done. So I could go like this. What number am I up to? C6. And so I've done that one, that one, that one, that one. And I could go just like this. C7. Oh, that is not a 7, Brooke. That is a 2. C7. Okay, I think I've got all the cuts. If I've missed any, just let me know. All right, so let's have a look at the values of the cuts. I'm just going to use yellow and hopefully you can see what's happening. So let's have a look at C1 first. So this cut through here. Remember, we're looking at the direction of the line. I'm just going to make these really obvious so you can see, because I know it's a bit blurry. Okay, all right, so looking at the first line that it cuts, S to A, and looking at cut 1, so it's going to hit that dotted line first, so I would pay that 8. And then the other line it cuts is down here, so I would also pay the 11, which is 19. And then however you want to do this, I might just go in order as they appear up the top. So looking at C2 now, so the first edge it cuts is up here, and again it's going to hit the dotted line. The direction is going to hit the dotted line first, so I would pay that 8. And following that cut down, it's going to hit the line between C and B, and C and B is the direction. So again, it's going to hit the dotted line of the cut first, so I would pay the 3. And then finally, the last edge it cuts is from C to T, and that is the direction, C to T. So again, it's going to hit the dotted line, so I would pay the 1. So that is 12. All right, so I've done that one. So moving along, I'm now going to do this little guy. Do I have a little pointer? No, I don't. I thought I had a little dot that I could point at stuff. Oh, I do. Look at me go. That's really hard to see, but I'm going to do this cut through here. So C3. All right, so the first line on cut 3, I'll just use a different color. So again, going from the direction of S to A, it's going to hit that dotted line first. So I am going to pay that. And if I follow that cut through, so there's the cut there. If I'm following the direction of this line here, up, so it's from B to A. So B to A, again, it's going to hit my dash line first, so I am going to pay that one. And following it around, so I'm over here now. So I'm looking at B to T. B to T, again, it's going to hit the dash line first, so that 5 is paid. And the last edge it cuts is the C to T. And again, it is hitting that dotted line first in the cut, so I will pay that. So that is 19. So I've done that one, that one, that one. So looking at this little guy here, so I'm here. I'm going to look at this cut, so C4. Oh, this little highlighter thing has changed my life, the little red dot thing. Look at me go, learning things. Right, let's go yellow. So looking at the first edge it cuts from A to T, it's going to touch the dotted line first, so I will pay that 3. And then if I follow that through, so it's got this line here as well. It's going to hit this one here. Now, if we look at the direction of this line here, where it cuts this one, let me have a look. So this one here, as you can see with the arrow there, it's going the other way. So the direction of the pipe is actually cutting into the solid line first. So we're not going to count that one. So that one is a no-goer. So we just don't add anything. If we follow that line through to here, it's going to hit the 11 from S to C. So S to C will hit the dotted line first, which is 11. So that would be 14. And you can tick those off. So like I said, I'm just following these in order up the top. You can put them in order like however you've labeled it with your cuts. However you do it is up to you, totally up to you. Okay, next cut. I really need like 1,000 different colors because this is ridiculous. Let's have a look at this little guy. So we are looking at C6 now, or cut 6. So the first edge it cuts is this one, which is traveling along here from A to T. And from A to T, it does hit the dotted line of our cut. So I do count that guy, which is, what is that, a 3. I was going to write an 8 for some stupid reason. Let's get rid of that. So 3 plus. Again, it cuts through B to A. So B to A is going this way. So it's going to hit the unbroken line first, the solid line first. So we don't count that one. So that one is not counted. Moving along the cut, we've now got from C to B. C to B is the direction. It's going to hit, moving along here, this line, it's going to hit the dash line first. So we can count that. That's 3. And then finally, this line in here from C to T. C to T, it's going to again hit the dash line, which is 1. So 7. So I've done that one. And then this squiggly one here, which is C5. So C5, we're going to count the 3. We're going to count the 5. We're going to So this one here, a bit tricky. So this line of the cut is going to hit the full line first, so I'm not going to count that 3. And then the 11 from S to C, it does count. So that's 11. So that is 19. So I've done that one. And then finally, we have this little guy there. So that is counted. That is counted. That is counted. So 3 plus 5 plus 1, 8, 9. Right. So now that we've done that and our page looks like this, we need to evaluate what all our cuts. So I've got 9, I've got 19, 7, 12, 19, 14, 19. And remember, maximum flow is the minimum cut. So we're looking for our minimum cut, which is 7. All right, so that is the maximum flow of the network. I'm super sorry this took 36 minutes to explain. Hopefully you will be able to go and have a crack at some of your questions. Remember, this is the first time you're seeing stuff like this, so it will take a little bit to like work out how to bend your cuts around and to make sure that you're cutting off every different way you can from the source and the sink. You're not going to be an expert at the start, but I guarantee if you practice it, you'll get pretty good at it. All right, so and also have a crack at your exam booklets. There's lots of good questions in there as well. So an exam type question, or in a SAC, you may have to look for all the cuts in a network. Or sometimes an exam question might just ask you to evaluate the weight of a cut or the value of a cut. So that's a typical exam question too. So yeah, good luck.